Chairman of Civil Engineering Division Board, members of Civil Engineering Division Board, council members, and Deputy Director Technical Engineer Sudhir Chakravarti to this webinar. I would like to extend a heartfelt welcome to our distinguished panelist, Dr. Prabhat Ranjan Kumar Soda, Senior Engineer R&D, Modulus Housing Private Limited, Chennai, Dr. Surender Manikam, Associate Professor Grade 1, School of Civil Engineering, Vellore Institute of Technology, Vellore, and Dr. N. Lingeswaran, Assistant Professor, Department of Civil Engineering, KL University, Guntur. Of course, we will be sharing their expertise on the next-gen infrastructure for a sustainable future. I also wish to welcome Dr. R. Prem Sudha, Professor and Head, Department of Civil Engineering, Akshaya College of Engineering and Technology, Coimbatore, who has taken the responsibility as moderator of this event. At this juncture, I would like to express my sincere gratitude to the principal and management of Akshaya College of Engineering and Technology for their continued support and collaboration with the IIA Coimbatore Local Center in organizing various events across different engineering divisions, including this event. Also, I'd like to welcome Dr. J. Pradeep Kumar, Honorary Secretary of IIA Coimbatore. I am pleased to welcome committee members, IIA corporate members, faculty, staff, and students from various institutions, as well as the participants from various sectors across the country for this program. This webinar highlights the rapid growth of infrastructure demands in India, which calls for innovative, sustainable, and resilient engineering practices. The theme of this webinar brings together three transformative domains shaping the future of civil engineering. Especially the 3D printing in construction is emerging as a revolutionary technology that can significantly reduce the construction time, minimize material wastage, and lower carbon emissions. I am confident that the discussions today will offer meaningful perspectives for advancing civil engineering practices. To all participants, I wish an insightful and enriching experience during this webinar. On behalf of the Coimbatore IIA Local Center, I once again extend my warm welcome to all of you. Thank you so much.
Thank you, sir. Good afternoon to all distinguished dignitaries, respected speakers, faculty members of other college, researchers, students, and participants joining us today. So, on behalf of the Institution of Engineers of India, Coimbatore Local Chapter, and the Department of Civil Engineering, Akshaya College of Engineering and Technology, I extend a warm welcome to everyone for today's technical webinar on next Gen infrastructure for sustainable future. It is indeed a great pleasure and privilege to moderate this insightful technical session organized under the aegis of Civil Engineering Division Board of the IEA. So on this webinar, in the contest, we have planned a webinar today. 3 resource persons. Today they are going to discuss and will highlight 3 transformative areas that are shaping the future of civil engineering: 3D printing and sustainable construction materials, innovative geotechnical engineering approaches, and advanced remote sensing technologies for water resource management. Sir, thank you for your welcome and presidential address, sir. Now it's the time, my honor to introduce a resource person. First panelist, Dr. Prabhat Ranjan Kumar Soda, Senior Engineer, R&D at Debrique Creative Labs Private Limited, Chennai, Modulus Housing. So, his research focused on the design and development of ultra high performance fiber reinforced concrete for prefabricated construction, intersection of sustainable construction, cementitious material and low carbon technologies. He focused on the development of eco-friendly binders and building components using industrial byproducts such as GGBS, fly ash, and construction and demolition waste, as well as the integration of carbonation curing, microbial induced calcium carbonate precipitation, and 3D printing to enhance the performance of earthen and cement-based materials. His expertise spans microstructural analysis, advanced material characterization, and computational simulations, enabling him to bridge laboratory innovation with real-world application. He has authored influential publications in prestigious journals such as Science of Total Environment, Cement and Concrete Composites, Construction and Building Materials, and the ASCE Journal of Materials in Civil Engineering. His work has significantly contributed to advancing sustainable infrastructure solutions and next generation materials, science innovation, and recognized as a dedicated researcher and educator. Dr. Prabhat is committed to driving innovation that aligns with global sustainability goals, inspiring young engineers and researchers to reimagine construction practices for a greener and more resilient future. Now I would hand over the session to Dr. R. Prabhat sir. Sir, now the session is yours.
Yeah. Am I audible?
Yes, sir.
Thanks a lot, Madam, Dr. Prema Shubha. Thanks for inviting me for this as a panelist. I would like to share my screen. Just confirm whether this is clear. My screen is visible or not. Is it visible clearly?
Our business owner.
Yeah, thanks. So, yeah. So the very first of all, I would like to thank all the panel members and the person who is conducting this program. And this is very important that we learn knowledge from different expertise, people who learn from different stages of their life, which will surely show the light to their life, where they are where they want to progress in life in a different sectors of civil engineering. So obviously civil engineering is a simple term, but it has several what to say several expertises like disciplines, whether you call it is what to say materials, whether you call it is surveying, or what to say analysis, design part, other things. So many things are there, right? So to bring all the different technologies and different sciences and different engineering practices, especially to develop the sustainable infrastructure, is only possible for civil engineers. Okay, so here today I brought specific research topics that I have practiced during my PhD, at the same time throughout my experience in the industry. So as a before starting, I think my voice is echoing. Okay, so like my mentor used to tell that life is nothing but a continuous journey from imperfectness to the perfectness. Okay, when we think about becoming perfect, we can try or keep our efforts to become perfect, but we can never be perfect. We think we can be perfect, we can never be perfect, but we will be in the journey of perfection, right? We try things doing perfect. So research actually starts perfecting ourselves and developing certain new technologies throughout the process, right? So in this way, currently there are very high demanding infrastructure challenges, or in high demanding infrastructure technologies that are really available for all the practitioners of civil engineers. If these technologies can be brought into the practice in the higher level, there will be surely lack of what to say, there will be surely satisfying results in the what to say, housing sectors or whatever in a quick development construction sector, all those things. So the global infrastructure demand is actually expected to be 90 trillion by 2050. And construction sector itself contributes nearly 38% of the global CO2 emissions. So we know that there are several disturbances in the ecology cycle. At the same time, there are disturbances in the contributing to the global warming because of the pollution, because of the vehicles emissions, right? So among all these things, cement production alone will account for the 7 to 8% of the global CO2 emissions. So there is a seriously need of transition towards carbon neutral infrastructure. So whatever we construct now without cement, constructing is, excuse me, I think am I audible? Okay, I received a call from her. Okay, I continue. So there is surely a need of transition towards carbon neutral infrastructure. So the current existing conventional problem with the conventional concrete is that there is high carbon footprint. What is high carbon footprint? Which releases enormous amount of the carbon dioxide into the environment because of the production process and maintaining process and demolishing process also. So altogether, how much amount of the carbon dioxide is emitting into the environment, and that is causing so much global warming, and that is causing so much disturbance in the ecological cycle, disturbances in the seasonal variation. So many things are there. So we can actually focus on these things by implementing several technologies like 3D printing, and by adopting low embodied carbon construction materials, all those things. And other issue with conventional concrete is durability issues. Okay, it is very easy and prone to cracking if it is not designed for specific performance, and it leads to corrosion and then thereby deterioration of the structure. The high life cycle maintenance cost is another problem with conventional concrete, because when towards the end of the life, or at least after 30-40 years of constructing any structure, there will be surely some amount of maintenance issues, large material consumption and environmental impact. So it is obviously so much amount of the material that is required, concrete is required to construct any mega structures or any normal housing kind of structures also. So alternatively, to reduce consumption of the material, thereby reducing the footprint of the carbon in the construction sector, these are some possible technologies that can be implemented in the construction field as well as in the research field. Currently, these are not highly established, but people are actually adopting these technologies to speed in, to quicken the construction process. So one specific interesting topic is, or interesting technology is, that people are exploring throughout the globe. As per the UN sustainable goals by 2030, we need to bring down all the sectors mostly carbon neutral. The technology should align with the carbon neutral technologies. That means the carbon emissions should be reduced. That's how the EV project has come, electric vehicles. But in construction, how we can reduce that? The only material, if I want to prepare a concrete, the basic ingredients are cement, fine aggregate, coarse aggregate, and water. Among all these, from the cement is the best thing, and that is what causes more amount of the carbon emissions into the environment, right? So how we can sequester this carbon dioxide is a major problem. My professor, when I was working as postdoctoral researcher at IISc in Center for Sustainable Technologies, Professor Sauradip Gupta inspired me to work in this specific area, and I also got inspired by several research outcomes that has occurred during the process of the research. So the basic information is that 30% of the global industrial CO2 emissions are mainly because of the cement production out of all the industrial emissions, whether you consider EV, electrical or other sectors, different sectors, engineering sectors. So India among all the countries, is the second largest cement market globally with continuous and growing production volumes among all the sectors or countries. And one more major problem is scarcity of the river sand. Now in future, now itself, there is a movement called Save the Soil, Save the River. So if you continuously dredge out the amount of the soil that is existing in the river for the construction purposes, there is a lot of changes in the ecological cycle because that changes the movement of the river, and other thereby other problems occur. So people don't want to use the entire amount of the river sand. That's why there is the movement called to reduce the uses of the river. So this is one specific problem, and carbon sequestration is a basic solution for it. So to address this problem of avoiding river sand, utilizing excavated soil from the C&D waste is surely one solution. Locally available soils. So we experimented carbon sequestration instead of using normal fine aggregate that is received from the river sand. We not also using RoboSand or M-sand. We utilized locally excavated soil. Whatever the soil which is available near the construction sites. For example, when we try to construct a foundation, what happens? There will be a lot of soil that is available due to the excavation process as a pit. The soil is directly utilized as a fine aggregate and incorporated into 3D printing, and we have beautiful outcomes of that. So again, introducing the CO2, just now we discussed, there are lot of amount of CO2 that is causing changes in the environment, right? So this amount of CO2 that is emitting out of cement manufacturing process can be utilized as a positive aspect when we utilize the CO2 gas as a curing gas. We know concrete should be cured immediately after casting, after demolding. So this curing process can be done directly by exposing these concrete specimens or concrete structures, especially in the prefabricated sector, into a CO2 chamber or CO2 gas chamber. So the other major problem here is carbon sequestration potential of 32,000 tons per day, which is equivalent to carbon stored in 50 hectares of the forest area. So buildings also can act as a carbon sinks, right? So when we expose these concrete structures to the CO2 gas, what happens? Basic science is that this carbon dioxide that is emitted from this can be bottled, and these C&D waste fines, whether it is locally excavated soil or C&D construction and demolition files, can be chemically washed, and they can be also utilized in sequestering process. That is one way of sequestering carbon dioxide into the aggregates, and directly the structure also can be exposed to this carbon dioxide gas that will sequester the carbon dioxide and forms calcium carbonate. So the basic science is that this carbon dioxide will react with the calcium hydroxide, that is a byproduct of the hydration. When cement mineral or cement reacts with water, that generates a gel, CSH gel, then calcium hydroxide. That calcium hydroxide reacts with carbon dioxide, and that generates calcium carbonate. Not all the calcium hydroxide is reactive calcium hydroxide. We need a specific pressure, we need a specific humidity, and we need a specific temperature where maximum amount of the carbon dioxide can be sequestered. That is what sequestration meaning. We are permanently converting this carbon dioxide into calcite. Unless and until you heat the calcite again to convert into reactive lime and CO2. So these construction sectors, or what to say, prefabricated industries can adopt this kind of science of curing using the carbon dioxide and improve this strength also. It also improves the strength because this calcium carbonate will densify the structure, then enhances the compressive strength and enhances the durability and permeability, reduces the permeability. So he's a professor, my inspiration. From him, I have learned a lot of things. So in his hand, there is one cube which is carbon sequestered, which is exposed to carbon dioxide, another cube which is not exposed to carbon dioxide. So he experimentally shown what is the difference in the strength between these two cubes.
So I have two building blocks in my hand. One is made using Portland cement and natural sand. And another building block here is made using Portland cement, CO2 treated recyclable fines, and then cured using our CO2 curing technology. So what I'm going to do here is I'm going to subject both of these cubes to strength test, and let's see how they perform.
So if you see this under a specific loading conditions, there is the one which is actually there in the first is block 1, strength due to conventional curing. That is, conventional curing is generally we cure in the normal water. So we get the strength, normal strength, whatever is expected. And the strength of the second block is shown 30% hike in the strength, the load carrying. The failure is, see if you see here, the cube 50 mm cube has failed at 82.4 kilonewton, and the conventional cube has failed at around 65 or 70. It will be close to that. So this is the strength difference in the first day itself, the very first day. So carbon sequestration can be done initial days only. After casting, immediately we must expose this, because that's when the maximum amount of the calcium hydroxide availability will be there for reaction process of the CO2. So this CO2 basically finally mineralizes carbon dioxide into calcite and improves the strength and permanently stores into the infrastructure. This is how carbon can be sink or absorbed directly reaction in the way of reaction. So that's how the construction can be it is one of the important aspect for the demolding process, faster demolding process, as well as faster deployment of the structures into the service. So it is useful in that way. And second thing is, very important thing is, everyone is interested in 3D printing. 3D printing, although we don't need any farm work for constructing any type of, almost any type of structural, framework, we can avoid molds, and we can construct any type of, any shapes, like practically impossible using molds can be done using 3D printing, as you see in this picture. This is one of the 3D printer that is called robotic arm 3D printer. So using which we can construct up to a certain height. And there are some other types of 3D printers that are available in market, gantry based 3D printers, using which there is a limitation of height. Until the height of the gantry only the structure can be printed. So there are limitations as well, but the process is very quick. You can construct a wall within a day. In fact, if you properly utilize the resources, you can construct within a day a structure also. All depends upon the science of development of material itself. So it is just like when we press a toothpaste, what happens? Material comes out, the paste comes out. So paste will not collapse on its own. It retains its own shape on the brush, right? Similarly, if you design the material using specific chemicals or viscosity modifying chemicals or viscosity modifying admixtures, the layers will retain its own strength. Okay, this is the process called extrudability, a specific technical word. I'm not going into too much technical details of 3D printing, but the applications of the 3D printing I just show here. So it is very much useful for affordable housing and disaster relief shelters. Immediately, if you want to construct any shelters, and complex architectural structures can be printed, and rapid infrastructure development. So these are some example structures we have experimented. So at IISc, Indian Institute of Science, when I was working as a postdoctoral researcher. So here, if you see, the left side one is called as marine tile. And this is actually process of printing a column with infill of bracings, cross bracings, square bracings. Here we have a square structure. So the color looks different from the cement, because we have not used only cement. We have used locally available soil, that is clay soil, which is actually non-expansive clay soil. That is, the mineral which is causing for expansion is montmorillonite in the clay. So we choose a material which is not having montmorillonite, or at least having very less amount of that. We choose it and sieve it, and we dry it. We directly developed the mixed formulations and we started printing. The quality of the layer and the extrusion quality of the layer, if you see, it is very smooth here. And it's very easy to print. So within this entire column is just printed within some 30 minutes. So in this way, we can build up. This is gantry based printer. So this is hopper. The material is manually fed into this hopper, and that is printing the layer. So this is a layer by layer construction technology, or additive construction technology, they tell. So a lot of learnings were there. Basically, I'm not going into too much into that. Maybe I can leave the platform for questions at the end of this. So these materials are highly low embodied carbon materials, because we are not using high amount of cement in this. We used very 30% cement only in this. It's very less. And there is another research where only using geopolymer, there is very less amount of the almost zero cement, and 3D printing was awesome. Structures were constructed at IISc. When you visit Bangalore, you can visit our printed structures still available at our research facility. So apart from that, this is one wall. Attempt to construct a wall also has done. So like this, we can construct. This is the time taken for this is around 2 hours. Our research scholar has printed this, and it was modeled in Fusion 3D. Then it is transported to the computer, where printer changes into layers. Then it is printed. So this is another research parallelly our collaborated university, IIT Roorkee. So we have done this as a part of our research work. So they explored using their locally available soils as a fine aggregate replacement. And you can see there is a lot of discontinuities in the surface of the quality of the layers. So from this, we can learn that there is difference in the quality of the layers, quality of the printed material based on the ingredients that we use. Not all the locally available soils are useful for the printing. We must test basic tests. So these are certain things, other things which they successfully printed with a good extrusion quality of the layers. The science is that voids in the conventional cement-based mortar are highly porous, whereas when you explore them, expose them to the carbon dioxide, and carbon is converted to the calcite, and that is highly densified material. You can see there is densified concrete. It's an example location only, where that SEM analysis, scanning electronic microscope analysis, we have done and we have seen. And we have also checked using Aviso thermofisher, where the calcite crystals are modeled, which are sequestered through the carbonation or carbon dioxide exposure. So it's a highly densified material. In the cube, a specific portion was analyzed using this. It's a modeling, basically 3D rendering of calcite crystals. So that was my research at postdoc, as a postdoc at that. And as we discussed, whole world is looking towards the sustainable goals, especially in construction sector, which we are responsible as civil engineers, or to develop a resilient infrastructure, cleaner construction technologies through C&D waste and CO2 utilization. That's what specifically we are addressing to these problems. And sustainable cities and communities by maximizing the utilization of CO2, and responsible consumption and production by promotion of C&D and excavated waste recycling as a new building materials. Obviously, we require less resources. At the same time, we can utilize high amount of available resources. Then third important technology is bio-based self-healing concrete or self-healing concrete, which is also very much focused element or focused research aspect by several researchers on the globe from past decade. In fact, my doctoral work is focused on this healing of the micro cracks. So basically, healing can happen in two different ways. One is natural healing and artificial healing. Natural healing means that cement itself, when crack occurs, or concrete itself, when crack occurs, naturally, because of the availability of secondary hydration products, certain amount of the crack will be closed. but that is limited to 0.2 microns, not more than that. So that healing is not going to close the entire crack. But when the crack more than 0.2 micron can be healed by introducing some healing agents artificially, can be chemical based or can be organic fiber based or by encapsulating bacteria. So I have taken an opportunity to explore, to experiment the healing efficiency of bacteria, especially which precipitates calcite. Calcite is abundantly available material in the planet Earth. In our bodies, whatever we eat, certain amount of chemical that is forming is calcite through our bones, through our teeth, right? We all have this calcite in our bodies. Like that, certain bacteria has the ability to precipitate calcite. That is called calcite precipitating bacteria. That can be encapsulated into lightweight aggregates or polymers or specific things, right? So then those aggregates can be replaced after encapsulation using normal aggregate. As we see, this is the process of how we form the aggregate, and then incorporate into the cubes, then testing the healing efficiency of that after several days and at several concentrations. And we found that it is highly healing was around 39% when compared to this normal conventional concretes. So we can see visually there are precipitation of calcite between the cracks that closes further entry of the pollutants, and the area is calculated using ImageJ here. Just brought in front of you this technology. People who are research minded can explore this at their depths. So we can see here calcite crystals that are precipitated by bacteria inside the pellet after cracking. So these were analyzed using EDX analysis, and we found huge amount of the calcite. It's a pure calcite. So benefits of self-healing concrete actually extended service life, and there is already people who are experimenting at Denmark. They have constructed a beautiful structure of very 1,000 square feet slab. So where they have understood after a year of exposing to several chemicals, there is no leakage of due to the chemical exposure. So we can avoid repairs if you can adopt such kind of things. And the final technology is modular and industrial construction systems. Currently, I'm working in modular housing, where people are experimenting directly constructing volumetric pots and optimizing topology, reducing the amount of material utilized, and reducing the weight of the structure without compromising at the performance. Minimal on-site work and transport direct to the site. So one specific thing is that utilizing EPS panels over this, utilizing some kind of ferro cement. So this is one specific model recently we implemented. We received a project from Indospace. So this is not yet completed. We are still doing. So the pod you are seeing here is completely a bathroom pod. Left side boys urinals and right side girls. And here the openings. These entire things were designed and placed in location in a steel frame. Then we utilized. Usually we need formwork to pour the concrete, right? So to avoid that, we utilized. I myself developed a specific material for spraying it, which should adhere onto the EPS panel. So you can see here how this material is actually sprayed over the EPS panel. So the rebound should be very minimal. Rebound means the amount of material after 100 kgs, if I am spraying over the panel, around 20% is falling down, right? So this is waste material, or we can utilize it further in the finishing or some other specific aspects of the construction here. So basically we can reduce the time of construction by using certain. One small example of that is that we can utilize for construction. This is at experimental stage. What the video in which you are seeing here, it's an experimental stage. So using which we have constructed a complete pod within a days. Actually, it is 6 days to 9 days time completing finishing and painting works all together. We have done this. So almost we can do that if we have a lot of resources like people who support all these things and placed over the. And finally, we deployed it to Gujarat. Okay, it's not here. From Tamil Nadu to Chennai, this structure is now it is in the transit. It is in the Rajasthan. Okay, so like these structures, we can transport at any location in India. And certain technologies like that are existing and people are bringing a lot of R&D into it. And I am currently working there to develop material and optimize the mix and structures, structural shapes, all those things. So in future, the integration of this digital construction into BIM, building information modeling, AI-driven design optimization, robotics, automation, digital twinnings. These are certain surface level and very much interested topics by several researchers. So in University of 20 people are working on digital twins. So like people can explore anything. Like in the process of perfection, we are achieving some products, right? This may not be perfect product, but to the specific point of time for the specific problem, that is a solution. If we are able to provide that, that's when our education is very much useful. Then future smart infrastructure, carbon negative construction materials, smart monitoring systems, circular economy, basically utilizing same construction demolition waste, resilient and climate adaptive infrastructure. So these are certain interesting topics, and people can focus on their research. If you are very much interested in research, can focus on these topics. Everywhere people are exploring this in materials. This is my domain, so I am telling these aspects. So yeah, I think I have consumed a lot of time. I'm going towards the end. That's key takeaways. Infrastructure must transition towards lower carbon materials to avoid these things, and emerging technologies enable sustainable constructions like this modular construction, and integration of biology, material science, and digital construction obviously improve the lessen the time of construction, which improves the satisfies the demand of construction needs in the society now. Rapid population increment and their needs to be satisfied, right? So innovation will define the future of infrastructure. So obviously there is a room for innovation. People are thinking and implementing their thinking in the products and can cause faster construction technologies. Although I don't want to bring down, this is we are all working very day and night to reduce this carbon emissions, and there were leaders causing some kind of generating millions of tons of CO2. So although it's funny, fact is that so meaningful decision should be taken at specific times instead of causing problems to the common public. I'm connecting this to our topic just to be an awareness, and being kind and humane is very important at the time. At the same time, being innovative and leadership. Okay. Anyhow, thanks everyone for giving me opportunity to present this and giving me a chance to as a panelist here. To entire team, it's a great work to bring all these people. Any questions and comments are welcome. Otherwise, we can move to the next panelist. Yeah. Thanks a lot. Am I audible? Any questions or comments? Don't hesitate to ask, or you can post in the chat box later. I can respond to yours.
Okay, thank you, sir, for sharing your thoughts about the global infrastructure challenges, problems with conventional concrete, 3D printed construction, and bio-based self-healing concrete. So we have seen the video presentation. It was really amazing. It was very wonderful session, and very technical points you have given. The emission of CO2, and we are the civil engineers. We have to protect the environment. So sustainable development goals we have to follow at 9, 11, and 12. So the future smart structures you gave how to control the CO2. It's a very informative session. So the question session will be after all the panelist discussion. We'll start. Okay. Thank you, sir. Thank you for your for sharing your thought. Once again, I would like to convey my thanks in your busy schedule. You have accepted our invitation, and the session was very useful. It was very new to all. Very interesting session. Thank you, sir. Thank you, Prabhat Chandan, sir.
Thank you, madam. Thank you.
Now, it's my privilege to introduce our second distinguished resource person, Dr. Surendra Manikam, sir, Associate Professor, Grade 1 in the School of Civil Engineering at BIT Vellore. He has an He has specializing in environmental and water resource engineering with a rich academic and research journey spanning across India, Germany, and the USA. He brings a global perspective to civil and environmental research. He earned his PhD in remote sensing from IIT Bombay, where his thesis was recognized with the Excellence in Thesis Award 2016. He further advanced his expertise as an Alexander von Humboldt postdoctoral research fellow at Friedrich Alexander University, Erlangen, Nuremberg, Germany, 2016-2018, and later as a postdoctoral associate at Duke University, USA, 2018-2020. Dr. Surender's research focus on remote sensing, synthetic aperture radar, cryosphere studies, disaster management and mitigation, and AI application in Earth observations. His scholarly impact includes contribution on high-impact journals, book chapters, and the publication on his book, Remote Sensing for Snowpack Monitoring and its Implication. He has received prestigious awards including Alexander von Humboldt Research Award 2016, Best Paper Award in Geomatrix 2014, and recognition for his doctoral work at IIT Bombay. His ORCID, Scopus, and Google Scholar profiles highlight a growing academic footprint with extensive gift. So I now hand over the session to Dr. Surendra Manikam sir. Sir, session is yours, sir.
So am I audible? Ma'am?
Hello.
Hello. Ma'am, am I audible? Audible?
Hello.
Ma'am, am I audible?
Yes, sir. Audible, sir.
Okay, sorry. I think there is some issue. I think my headset. I just checked once with my headset.
Okay, sir. Thanks.
So is it audible now, ma'am?
You can start now, sir.
Yeah, yes, ma'am. So I hope
Okay.
hope I am audible, right? Okay.
Ah,
So can I
audible.
So can I share my screen?
Okay. Okay, you can share it.
Okay, very good afternoon to all. I think hope the screen is visible to everyone. So, okay, the topic is relevant to the next generation sustainable infrastructure. So, however, I am not going to talk much about the infrastructure and other things, but I will tell like how a infrastructure can be monitored using advanced technologies and how it would help to make a sustainable infrastructure in future. Because now the major problem is that like everywhere we are facing a lot of disasters, right? Even earthquake, flood, and everything. So the major problem for the infrastructures are due to these disasters only. So if we are able to have a resilient infrastructure for disasters, so that is almost a kind of a sustainable. So here I'm going to talk like how we can monitor these infrastructures using a remote sensing technology. I will explain the basics, principles, and how it is working and all these things. And I will also show some of the examples like in the real time, how the remote sensing concepts are used for the disaster monitoring. So this knowledge, of course, help you to apply in your own field. Maybe a specific kind of infrastructure, or maybe a entire city, or maybe a district kind of places, how you can utilize this kind of a knowledge to monitoring the different infrastructures. Okay. Okay. So sustainability, okay, particularly if you link with the disaster. So the main thing is like, if you want to monitor the sustainable infrastructure, the first of all, the infrastructure is supposed to survive during a disaster. If it is not survived, we cannot name it as a sustainable infrastructure. So how we can do this thing, the sustainability of the buildings or maybe any kind of infrastructure, how we can monitor that. So first of all, we need data about a particular infrastructure. So this can be achieved through multiple things, like maybe we can use the satellite data, because ISRO and many space organizations nowadays launching a satellites. So which is providing a continuous data sets, mostly which is available openly. Okay. So how this data can be used for the infrastructure? So this data, first of all, we have to process and we have to get the record information. So this data can be analyzed for a specific kind of information. For example, my interest is to see that now, like in Coimbatore, like we are having a multiple bridges. So maybe some bridges are newly opened and some bridges are quite old, right? So maybe how the stability of the structures, maybe we have to see the health of the things and all that. So either monitored using a remote sensing kind of sensors, or maybe drones kind of things, or maybe IoT kind of sensors. So you can easily utilize that to monitor the health of the particular infrastructure. So if we able to find something, okay, some kind of damages or some kind of corrosion or maybe some kind of cracks or something, so you have to make a plan to strengthening that, okay, strengthening the infrastructure, okay. So maybe you can use the different materials, or maybe not. Nowadays, they're like self-healing and many things are there in the civil domain. So maybe how we can utilize that physics or maybe the civil engineering idea into the building or strengthening the maybe the damages or something. So that when you do these things, because like building or maybe constructing a certain kind of infrastructure not alone the sustainable, we have to continuously monitor whenever it is having some kind of issues, we have to fix it out, okay, so that it would stays for long and long. So that can be, we can able to achieve the sustainability, okay. So now I will just completely, because this is the overall like idea, like how the technology kind of remote sensing can be utilized for the sustainability of the infrastructure. So, but what is remote sensing? Okay, remote sensing means, of course, it is a information which you can acquire about any kind of object without actually being in contact. For example, as our human body, we are having a multiple remote sensors. For example, our eye, I can see anyone and I can observe about them. Like I can see their traces, or maybe I can see their height, weight, and all this information without, I don't need to go and touch them. I can just sense by my eyes. Even my nose will tell about some information, some smells and other things. My ears will tell about some kind of a sound and other. So it means like as a human body, we are having some sensors, which is the remote sensors. So the same concept they used in the satellite. Okay, satellite, because how you are taking a photograph, similar thing. So they send some kind of cameras, it's a kind of sensors. So they flow in the space. So it continuously captures the photos of the entire globe. So maybe wherever we need, that can be, we can utilize to monitor the changes, what has happened. Okay. So generally, when you look at the remote sensing, there are different components. First one is the energy. Okay. So energy is you must need the energy. For example, there are two types of remote sensors are there. One is active, another one is passive. I will come in next few slides. So first, passive, the important source of the energy is that sun. Okay, because if the sun is there, so the sunlight will fall on the different materials and it reflects. So when it reflecting, the sensor will capture that. It's simple like the photograph. When you take a photograph in the good sunlight, it appears very clearly, nicely. But if your camera is not having any kind of flash or something, if you take a photograph in the night, you may not able to see anything, right? The similar concept. So we need a sunlight as the source, so which is reflecting by the materials. So that can be sensed by the sensor satellite. So which will be transferred, that data will be downloaded from the satellite. So which will be processed and analyzed, used for the different applications. So this is the overall view about the remote sensing concept. So here that medium, we need a medium, because the satellite is somewhere, okay, the object is somewhere in the earth, and we are receiving the signal in somewhere, and we are processing, we are transmitting. So everything we are doing it in different places. So we need a medium. What is exactly carrying the information? So this is called the electromagnetic spectrum. You all know the electromagnetic. So mostly we use the particularly for the optical remote sensing. Optical means visible. So we use blue, green, red energy. It's 0.4 to 0.7 micrometer wavelength. We use it to capture the things. And also we use near infrared, mid infrared till microwave. We are extensively using it for the remote sensing applications. So as I told, there are two types of remote sensing. One is the passive, another one is active. Passive means we need sun energy must. Okay. So what does it mean? So we cannot capture this satellite information during the nighttime, or maybe if there is a bad weather conditions like cloudy, or maybe it's completely dark or something like that. Okay, so means it works only when the perfect weather conditions are there as well as good sunlight is there, right? So that's what it is a problematic, because it's extensively used by globally various applications, but it is having some limitation that we cannot use it for continuous monitoring. For example, if there is a flood or maybe earthquake happened in the midnight, okay, if you want to capture that image and you want to see what are the images has happened, you may not be able to do it using the passive remote sensing, because it's a problematic. But when you go to the active remote sensing, it is having its own energy. It's nothing, because now even when you go in a bike by high speed, even it displays the speed in the roads, like you are going by 70 kilometers per hour, 80 kilometers. How it is doing? It is continuously sending the radar pulses and it is estimating the speed, okay, based on the return signal, okay, how fast you are coming. Similar way, it is also sending the using the radar as the signal, okay, which transmits to the Earth surface. Whenever it is reflecting, based on that, it is giving the information about the Earth's object, okay. So as I told, there is the optical, passive and the active, but microwave is also having a two. Optical means the visible and infrared, only we have passive, but microwave we have two, one is active and passive. So active is nothing but it's having its own energy. Passive is that there is a reflectance, because in night time you can see like in the now we are in the almost in the summer. Maybe you can see in the summertime, maybe in the roads and all in the night time it's getting cooled. So it means like a lot of energy will be, the heat energy will be coming out from that. Okay, so that is, it is a kind of like thermal energy. So which can be also satellite can capture and tell what is the land surface temperature and other things. Similar way, very minute level of microwave energy also will be reflected in the night time. Anytime it will reflect. So that can be also used for the remote sensing applications. Okay. So there would be a different thing, like the overview is that the optical remote sensing is only passive, so which is used in visible, reflect and near infrared and thermal energy, and also microwave is both active and passive. Active is we used for the simple backscattering, it is having its own energy. Passive is that its energy when it is released in the night time or any other time, but the energy would be much less. We cannot use it to monitor only a small town of the Coimbatore and all. It's not possible. We have to do it for, if you want to use this energy passive, we have to use it for the large area, because the energy is very small. To sense that, we need large area to get some information. Okay. So there are optical sensors in different spectrum. They use it like green, blue, and near infrared and all these things. So which is just nothing but it's reflect or absorb the light, and based on that we are getting. So I will come to that application. So when you are talking about remote sensing, the most important thing is like what are the different type of remote sensing. Okay, see, we just seen two types of remote sensing. One is active and passive. Another one is that what type of the sensors the particular remote sensing system is carrying, whether it is a panchromatic, multispectral, superspectral, or hyperspectral. Okay, so panchromatic is nothing but you are using different wavelength, right? Blue color, green color, yellow color, sorry, not yellow, near infrared and all these things. Okay, so whenever the energy is reflecting from the different wavelength, we are combining everything to make it as a black and white. We are not assigning a different color to each band. We are just combining everything. Okay. So when you are combining these things, you can see very clear, detailed information. Okay. Means the image looks more detailed, but you cannot see any kind of a colors. Okay. But when in the multispectral, you can see the colors, but you have to assign different. For example, like a particular area which is having more vegetation. Okay. But I am using green, blue, and a red band to monitor that area. What happens whenever the green is there, more vegetation will reflect more green energy. So that entire area looks more green only. Blue and red will be much less. So even though if I combine, so I can see mostly the green dominant only. So that we are assigning a different colors. So the resolution will be degraded, but we can see the in detailed features, because I can see the water and the other features more clear. Right. So super spectral means it is having a more band, okay, more spectral bands. It is having a 36 to 40 bands of the energy they have, so that we can see small changes. For example, if there's a lake water or maybe a pond water or maybe a how much the algae is there in the water, more greenery. So all this, even water itself, I can distinguish the different things when you are having a more spectral. So another one is the hyperspectral. This is more advanced. I think you can use it for various applications. For example, a crop, whether the crop is healthy or maybe it is having any kind of a disease or water stress is there, or maybe if you are for geological applications, if you want to use, you can see is there the particular area is containing any kind of a material like gold or silver or something, because it is very minute. For example, red color itself, for example, you can see everyone is wearing a red color t-shirt. For example, in case in your university, they are telling, okay, everyone, tomorrow is a green day, so everyone wear green dress. So not everyone wear the same tone of the green, right? Green will be varying from dark to light. There are multiple. So that each and every differentiation in the color can be easily identified using the hyperspectral. Okay, so it means it is having a multiple spectral wavelengths, so which can be reflected more precisely based on the small changes in the characteristics of the targets. Okay. So the another one is the spatial resolution, which is very, very important. So because you are using it for which application you are using it. Okay. For example, if my application is to monitor buildings in the university, so I need more detailed information. Maybe satellite data may not work. I can use the drone. So it gives the information in a centimeters resolution. So, but if I want to monitor the entire Coimbatore, so I need at least a little bit coarse resolution. At least the resolution can be in meters. But if I want to monitor entire Tamil Nadu, I can go even 30 meter, 40 meter like that. If I want to monitor entire India or globe, I can go a little bit coarser, because based on the application, you can select it. Okay. So this what, like as I told, based on the study which you are using, you have to select the resolution, spatial resolution. Okay. So spectral resolution, we have already talked about that. Okay, just skipping it here. So then the radiometric resolution, it is very, very, because there are 4 types of resolution. Spatial resolution is the pixel size, whether you are using it directing the building or lake or maybe entire Coimbatore or entire Tamil Nadu, and so accordingly you will select. Spectral resolution is the colors, how many bands you are using for the capturing the things. Okay. Another one is the radiometric resolution. Radiometric resolution is like, if you are using the radiometric resolution more, the detailed information you can get. It is nothing but the nowadays we are purchasing the smartphones with when you are going to buy new smartphone, what are the features you will look at it? The major thing you look at is it's a camera space, it's a pixel, right? Megapixel. So if the megapixel is more, means it's able to store the more detailed information, more radiometric resolution. Okay. So for example, if you can see at the bottom 1 bit. Okay, this means the 2 levels only it will have. So it means 0 or 1. Maybe even though it is having a multiple features, I can see either black and white. But either way, if it goes to 8 bit in the top, I can see 256 levels of the variation I can see. Even the buildings, I can see different colors. In the dark pixels also I can see. So it means small variability in the future can be easily stored. Okay, that's what it's called the radiometric resolution. So we need most of the time everything high radiometric resolution, high spatial resolution, high spectral resolution. Is it possible? No, it's not possible, because if you are going to have high spatial resolution, of course, you cannot store too much of information into that. Of course, the radiometric resolution will decrease. Okay, so of course there will be a trade-off is there. But the important another one is the temporal resolution. This is a must, particularly for the context of this presentation, because we need to monitor the infrastructures. So if you want to monitor the infrastructures, mainly, for example, in case there is no kind of a hazards, or maybe nothing has happened, no flood or no kind of earth has happened, at least we need an image every year once. Okay, so that we can see any damages in the infrastructure has happened. Okay, so that time the temporal resolution is even not 1 year, at least even course, maybe every month 1 image if it is available, that's enough. Okay, but in case you want to, there is a flood has happened today, so I have 1 image yesterday. So if I have another image tomorrow or maybe today, so the temporal resolution is only 1 or 2 days. So that is most important for disaster kind of application, because I can see due to the earthquake or maybe a flood, how many buildings in that area has damaged, what are the kind of buildings has damaged, so that immediate assessment, I could able to make it out. And if the building is partially damaged, okay, whether it can be any retrofitting or something can be done or not. So that can be assessed. Okay. So the importantly, so far whatever we have seen is like the remote sensing concept. There is a types of remote sensing and the importantly resolution. There are 4 types of resolution: spatial, spectral, radiometric, and temporal. So this is very, very important based on the application which you are going to work. Okay. So another one is the false color combo. So how I have an image. Okay, it's giving a different colors and the bands, everything. So I want to see how to look at the image. Okay, how I can infer the information. Okay, so there is a various way to do that. There is a composite. It's called false color or maybe natural color. Natural color is that green means we have to assign the green color. Blue means we have to assign the blue color. It's a naturally, because water looks blue, you will assign blue color. Green vegetation looks green, you assign green color. Okay, so then the natural color looks like this right color image. False color composite is like you are changing a different color. For example, green I am assigning blue, red channel I am assigning green, and maybe red channel I'm the another band I'm green I am assigning the red. So why so? Because here the vegetation looks more green. So why so? Because sometimes that wherever the vegetation is dominating, so that time the features can be more clearly classified compared to the normal NCC. So I can show some pictures here. You can see this is a true color, natural color. This is the false color. So you can see whenever the water and the vegetation, here the red color is nothing but the vegetation. This green and yellow, this looks like a water. Okay. So this kind of features can be more clearly, precisely can be classified. Okay. That's what the false color composite is mostly useful when you are look at certain kind of specific applications related to the vegetation and everything. Okay. Okay. So this is one thing. Okay, I made composite. I can look at the color image. So how can I interpret what exactly? Because it's a satellite image, it looks a lot of features are there. So how can I look at whether because everything is looks here because it is the false color composite image. Okay, we know that red is nothing but the vegetation, green. Okay, any forest or vegetation. So you can see here there are a lot of red patches are there. Here dark red patches are there. Okay, how can I interpret that? Okay, so there is by interpreting that then it's a specific skill. It is called there is a various parameters you have to use. It's called keys they say. Okay, it's the interpretation keys based on the size, shape, tone, texture, and other thing. So based on that you can classify that features in the satellite images. Okay, for example, tone. Okay, if the tone is too dark or maybe light. Okay, based on that, you can see where the more reflectance comes or less reflectance comes. Okay, so for example, if there is a river, okay, river might it's more smooth. Okay, it's a mostly specular reflection occurs. So it means it won't looks more dark. Okay, so in similar way, if there is a vegetation and other thing, it reflects so strong. So that the tone, how bright or strong it is there, based on that you can classify. Another one is the texture. For example, here everything looks green. Everything is a kind of a forest only. But how? Because it looks the texture is differing, right? So here there is a different texture. Here organized structure. Here it is completely different. How can you classify that? So you have to look at the texture, how it is. For example, here you can see this is a more organized. It's a plantation they have done. So here it's more rough. It's looks like a forest because it's not more organized. It's a mixed kind of thing. So here it's a grassland. Okay, even though it is a forest, so you can see everything is green. So based on the texture, you can classify what exactly, what type of green it is. Okay, and there is a size. Okay, it is very, very important. Okay, so for example, there is a lake and the pond and maybe river is there. Everything looks sometimes blue or maybe dark color. Okay, so how you can distinguish whether it is a lake, pond, or river? You all know, right? Pond may be smaller, lake may be a little bit bigger, river may be a continuous system. So based on the size, you can classify whether it is what type of a water body it is. Okay, and shape. Okay, so for example, road also looks like dark only, but it is not like rivers. Rivers is like more meandering, like more. It won't be more straight. Okay, but the roads are like more curves and the saves will be there. So based on this, you can classify whether it's a railway roads or maybe a normal roads or maybe railway tracks or roads or maybe a rivers or something, you can easily classifying it. Okay. Or maybe shadow. So the shadow indicates like it's a tall building or maybe a tall trees. Okay. So that can be helpful to identify, okay, there is a trees that is there. Okay. And also maybe association, you have to look at nearby the buildings, what kind of other features are there. Okay, based on that, you can classify whether it's an industrial area or maybe it's a completely community. Okay, or maybe it's a cricket stadium. Okay, all these things you can classify. Okay, so these are some of the things. So maybe can anyone tell like what exactly it is? This green mixed with some kind of patches of gray color. So how it looks? Maybe now you know the interpretation keys. Okay, it's just completely organized. So it looks like, of course, agriculture areas. Okay, because it's a completely patterned, organized. Okay, and what exactly it looks? We have already seen this example, right? Not organized. It's also green. Okay, green means of course it's a kind of a vegetation forest, something like that. But it's not organized, and also it looks like little bit mountainous areas. Okay, so where it would be forest area. So then it is what exactly it is. This also looks green, but it is a kind of circle and mixed with some kind of a square patches, square and rectangle patches. So what exactly it is? So it is a sprinkler. Okay, sprinkler irrigation. Mostly some parts of the Western countries they are using, and India also some part they are using it. Okay, so it means everything is green. So I can easily classify based on the structure, orientation, shape, and other things. I can classify what exactly it is. That's what you have to learn when you look at the remote sensing image to understand what exactly. Okay, what exactly this one? I told association, right? Okay, there is one white building is there. Beside that, there is one river is going on, and maybe some good forest and other structures are there. What is this? I think most of you might. Any guess? Okay, of course, it's the Taj Mahal. Okay, so of course, Yamuna River is there and everything. So it means satellite gives the information. By look at this, you can see that. Okay, so here you can see maybe forest and other things we have seen already. Okay, there is a one water body here. There is a small water bodies, and maybe there is a one big water body is going on. So how do you classify it? What is this small water body? It is a lake and ponds. Okay, and maybe this small one is the lake. Sorry, this one is the pond, this is the lakes, okay, bigger one. Okay, so and also tone, okay, whether different season, the same area, forest or something also, the tone will change, okay, based on the greenery. Okay, that also you can interpret. Maybe as I told, maybe association. Okay, the industrial area means maybe the buildings may be isolated, not much other infrastructures nearby would be there, because industry they may be a little bit isolated area. So that can be easily connected. Of course, it needs to be connected with the roads and other things. So based on this, you can easily classify. Okay. So this is what the remote sensing concepts has to be utilized to understand the futures. Okay. Okay. So the remote sensing can be used in different applications. So I will just skip this part because this I already doesn't look like a color, but it gives some kind of information where the optical, maybe the color image cannot be acquired. For example, when sun is not there or when there is a cloud completely. So that time you can use the micro remote sensors to get the information. Okay. Okay. And say, for example, simple example I'm giving here. You can see here, there is a cloud. Okay. You in optical color image, it looks only very few parts. Remaining part is completely cloud. But at the same time, if I capture the radar data, I can see all the features very nicely. So that's the advantage of having it. But it is only black and white. You cannot see any colors because it's a simple backscattering one. Okay. Okay. So I'm just skipping these things. So there is a different applications you can use the radar data. And I will directly go to the disaster. So how these concepts, remote sensing can be used for the disaster. So there are various disasters happened in India. So few of them I just put it here. So the Kerala flood to 2018. Of course, recently Wayanad also has happened. Okay, many people dead, lot of buildings and other things passed away. Okay, so this is a Kashmir flood happened in 2014. Around 500 people dead. A lot of bridges and infrastructure has lost. This is Uttarakhand flood. I think this is the before and after. So how remote sensing helping us to determine like what are the building has damaged, what are the changes has happened after the flood. So this is the, of course, tsunami. Okay, so still many publications are coming up based on the damages and assessments and maybe they are look at even the post-disaster development also. Maybe after, during the tsunami, what are the things not there? Post-tsunami, what are the things has happened? What are the developments has happened? So that also they are reporting and monitoring it. Okay. And also Gujarat earthquake 2001. So this is the Odisha super cyclone every year, because earlier we know that yes, Odisha is highly vulnerable for the cyclones. So now also, of course, but they are having a very good warning system. So nowadays we are able to track where the pressure has formed, which way it is moving, all these things we are able to track it very nicely. So that's very important. Actually, that is one of the added advantage, that we are able to protect ourselves from such kind of disasters. Okay. So how this remote sensing will help? Okay. So for example, this is the New Delhi in 89 and 2018. You can see the changes. The purple color, it's nothing but it's almost red mixed with the greenery. So the purple color is the urban areas. So we can see easily the Burhan and other areas were not much developed, Noida and all. You can see how the urban areas spread it. Urban sprawl, you can easily monitor. So now maybe is there anything has happened, damage or something, or any earthquake or any kind of things happen, we can easily locate that area and look at it, how much area damage, what are the problems that has happened, all these things. So this is the Dubai. So 2000 and 2012, they developed a lot of infrastructures in the ocean. So that can be easily, clearly can be noticed using the remote sensing observations. This is the Pulal Lake, which is in 2018. So Pulal, of course, we know that it's one of the major drinking water resources for the Chennai Corporation. So when it was completely drained in the same period, almost May, June, in 2019, so we can easily monitor, okay, whether how much water resources are available for the continuous coming summer. That can be also estimated using the remote sensing. So this is spring flood happened in USA. So you can see that how much the river width and other things has increased. Okay, overflow of the river system. This is the Chennai flood. So you can see wherever the water stagnant, maybe the water body before it was not. These are before, it's after. You can see this is Indian satellite, Cartosat 2E. So you can see how much water trapped in the urban areas in the Chennai. Okay. So this is the Poneri and other areas, a little bit Chengalpattu and other those regions. So you can see the water body trapped. And this is recently happened, I think, Tarali, okay, Uttarakhand, due to that kind of landslide. So this is the before. You can see the buildings and other infrastructure after that. So it means everything washed out. So that can be easily monitored. You can easily check it out, the number of buildings, number of people were living. So how much has gone, how many people might have disappeared, all these things you can easily estimate it. Okay. This is small landslide has happened in the Switzerland. So that also you can see before the image, it was not there. So after that, there was a change. This is the Wayanad, as I told, right? This is the crown of the area where it started, how it has slided. So all these things you can monitor. And there is this is the same, the Wayanad landslide area. Okay, more detailed pictures of these things, where it started, how it has slided, and what are the things has washed out. So this is one of the interesting thing, like in Tiruvannamalai district. Okay, Tiruvannamalai, we have that hill, right? Small hill. So where there was a landslide in, I think 2024, about 7 people dead, including 5 children. Okay, so we can see using the, see that this is a small hill. So due to this kind of, this is completely due to the rainfall. You can see there are a lot of changes has happened in the hill. Okay, there are a lot of area washed out. It's at the uphill. So not much damage has happened to the people. But over this small area, when the damage has happened, the big rock fell down. So that 7 people dead. So this is a earthquake in the Myanmar. So the bridges has damaged and the building collapses can be monitored. Maybe you can see the building. This building was not there. So this building was not there. So you can see the changes between the 2 images before and after. So it will easily help you to identify the damaged or maybe the collapsed buildings. Okay. So this is something, wildfire has occurred in 2015. So this is the before image. You can see this completely greenery. So after that, this entire area has been washed out. Okay. You can easily map and see how much area in hectares, okay, has been destroyed due to the forest fire. Okay. So this is due to the storms happen in the USA. The maybe the color has changed. It's completely mud has fallen into the entire river system. This is kind of a tsunami. It's a small iceberg has broken. So due to that, what are the damages has happened? So this is volcanoes, okay, the before and after. So due to the volcano eruption, so how it is flowing. So before that it was formed, but after that there is a lot of plumes has been emitted. So this can be easily monitored. So this is our Chengalpattu region. So this is nothing, it's not optical data. So far, whatever we have seen is optical. This is microwave data. So microwave, even the cloud cover is there, it gives very clear. The dark pixels are water bodies, the existing water bodies. Even the river system also not having any water that time. But after the flood, you can see how much water is there in that over that area. Okay. So I just stop here. So it means that we are having a remote sensing very good tool. Now data is openly available. So this can be extensively used for based on the application and the area, the infrastructures can be monitored. So then of course, based on that, the remedial measures can be taken. Okay. So this is my email ID. So if you have any questions or clarifications needed, you can feel free to write to me. I'm happy to answer. So thank you very much. Any questions? Ma'am, it is done, ma'am.
Am I audible, sir?
Yes, ma'am.
Okay, thank you, sir. Thank you, Surendra, Dr. Surendra, sir. A few things I missed to introduce about you, sir. So this is I would like to highlight about you that SAR has an high impact international collaboration with agencies like JAXA, DLR, CSA, and currently serves as the Vice Chairman of the IEEE GRSS Madras chapter. So thank you, sir, for your valuable presence and for sharing your thoughts about advanced and application remote sensing technologies for water resource management, optical sources, resolution concept, SAR application and open sources and advantages. Thank you, sir. So now I hand over the session to the third speaker, Dr. Lingeshwaran, sir. Now it's my pleasure to introduce our third resource person, Dr. Lingeshwaran, Assistant Professor in the Department of Civil Engineering at Konaru Lakshmiyya Education Foundation, Andhra Pradesh. So his research interest includes sustainable construction materials, recycled aggregate concrete, fiber reinforced concrete, and structural engineering. He has published over 60 research articles in reputed international journals indexed in Scopus, Web of Science, with more than 350 citations and an H index of 11 Scopus. He is actively involved in structural consultancy and has recently designed hospitals and hostel buildings with built-up areas exceeding 80,000 square feet and 135,000 square feet respectively, along with consultancy in structural design, steel checking, estimation, and project planning. So Dr. Lingeshwaran sir is a recipient of several recognitions, including the Excellence in Research Award for Structural Application of Fiber Reinforced Concrete for JRESM Journal, the Best Feature Award from KL University on 4 occasions, and the Best Researcher Award for his contribution to civil engineering research. So now I would like to hand over the session to Dr. Lingeshwaran sir. Sir, so you can start.
Yes, madam. Thank you for your introduction, ma'am. Thank you very much. Hope my screen is also visible and my voice is audible.
Visible, sir. Visible and audible. No issue.
Thank you, madam. First of all, thank you for this opportunity. So in this, I will take few minutes and I will close the session. Why? Because already 2 speakers they completed. They explained in very well manner. So my topic, I am going to explain about the case studies of a commercial building. So why we are saying to next generation infrastructure for a sustainable future. Actually, yeah, madam, my slide is moving, correct? It's changing.
Yes, sir, it's moving. No issue.
Okay. So I took one case studies. So I took one case studies of a commercial building. So for make a commercial building, we will
proceed with the soil report, plans, then details of columns, PT slab, PT beams, calculations, Smith designs. So many parameters will be there to start a project. So with this, we have the architectural plan. So if we have the architectural plan, we will go with the structural plan and we will go for implementation in the site. So why I am showing this architectural plan means, first of all, you have to know how the infrastructure is developing in and around the place and in and around the states. So actually, I am staying residing in Vijayawada. It is a new capital of Andhra Pradesh, actually Amravati. So from my place Vijayawada to the Amravati, it is around only 30 kilometers. So you can see here so much of development. So recently they given new starting Quantum Valley is there. Then so many infrastructures are developing here. So I took one case studies what I worked in this. So how I am come over with for next generation, how we can utilize the material further. So this is the architectural plan. So this is a slab 1, PT slab 1. It is a total 4-story building. So you can see this is a PT slab 2 and the total square feet is around 35,000 square feet total area. So and this is followed by PT slab 3 and the PT slab 4. So first 2 floors they are taken by west side. So that is for purchasing those things, west side they took. And the third and the fourth is occupying by a hotel. So this is the one. So this is the time of construction. It is to get understanding about the PT slabs. So this is the slab one, you can see. I think you can able to see the video. Actually, audio I didn't get anything. That's what I'm giving. So why I am showing this video means, like client wants entire space and the utilization should be very clear. So he don't want to waste any space. Anyway, you can know when we will go to the site or anything, a client always want to construct his slab or construct his slab area, everything end to end. So here the motto is how utilizing we can able to come up with new materials and how can we make, like if we go to RCC slab and if we go to PT slab, I think if I say about PT slab, so we can reduce the number of columns and we can reduce the number of beams. Like if it is you can see in this right side, it is around a 32,000 square feet plan area, but you can see total we completed within around 32 columns only. So this is the, yeah, you can see here, this is the main slab part 1 and part 2. So in this entire thing we completed within 18 columns and lifted place we kept the columns, staircases, everything will be there, everything, some attachment columns. So when we will go to top, the columns will get reduced. So that's the reason we are going to PT slab. So why I am showing this image means, you can see the resources, how much amount of sand will be there. Actually, it is very near to the Krishna River region. So in the Krishna River region, the soil will be available, sir. So when we will go to for footing, we have to go with a very heavy foundation. So you can see here how the mat is there, and you can see here mat, bottom mat, top mat, and after the concrete. So this is the one, the raft is completed. So this is the excavation of soil tank. So you can see here, these are the touch files. Before going to start the project, we kept the touch files to resist the soil should not fall down from the neighbor land or anything. That is the purpose. So you can see here how much PCC and how the concrete we are pouring by using PCC everything. So you can see here the quantum of concrete, reinforcements and rafts, everything. And this is concreting time. And this is reinforcement details for a single footing. Yeah. So why these many things I am showing to you people's minds? You can see this is the sample details, and the concrete is going to follow. So yeah. So I actually first of all I started with a commercial building. Like I informed 4-story buildings, and 4-story building I informed that PT slab 1, 2, 3, and 4. So followed by I shown some raft footing. So you can see here this is a raft 5. Actually in our entire 35,000 square feet area, we have total 5 rafts. So in the 5th raft, this is the steel calculation. You can see we are using 16 mm dia, 14.82 tons, 20 mm dia, 21.21 tons, and 25 mm dia, 9 tons. So total here we are using around 40 tons of steel here. So you can think about alternate. Actually, this is the footing. So we can use GFRB bars. So that GFRB bars, how you utilize in our lab how we use it, everything I will show in the upcoming slides. So I'm giving a hint. So you can think like, see, when the commercial building, when we are going to give the structural design and the wetting design, client is asking about the quality. So what client is saying means when we set about fly ash, introducing a fly ash or introducing a fiber reinforced concrete, first of all, client is not ready to convince that why we need to go for alternate materials. For us, no need of saving the amount, or there is no need of any economical structural design or no need of any economical materials. We will go with the normal tradition method. But as a civil engineers and structural engineers, we have to teach them this is the thing, this is the reinforcement details we are providing. We can alter the material like that. We can do with some proofs. So the proofs I will show you how we will convince the client everything in the site. So you can see here ramp section, in the ramp section how much amount of reinforcement and how much amount of filling of we are taking out the soil and again filling. So the soil where we are taking we can use for another resources. You can see here how much amount of, actually this is the road level. From road level we went around 15 feet down. We went around 15 feet down, then the gap, then soil filling, then we are going with the next step, PT step. So this one will become a cellular activity. So this is after the completion of soil filling. The next one is compaction, and we will keep termites. These all are normal procedures. So you can see here. So this is the total PCC utilized in this 35,000 square feet land area. You can see here, this is the total final area after reduction everything, 28,728 square feet. So we went with the 5-inch PCC. So total cubic meter we use it is 339 cubic meter of concrete. So 339 cubic meter of concrete means for 7 cubic meter of concrete we are using 12 mm 417 kgs and 20 mm 730 kgs. Around we are using almost 1100 kgs, 1.1 tons of aggregate we are using. So when we will go for total 339, we are using around 55.54 tons only for PCC. Actually, we are using around 55.54 tons of aggregate we are using only for PCC. So you think when we are going to another 5 slabs, how much tons of aggregate we are using? So that's what we need some alternative. We have to go with the recycled aggregate. So when we are going with the recycled aggregate to check about the strength, we can use fibers like 0.5%, 0.25%. These all are we have to make a read and we have to inform to the client. So after these many things I informed and we went to him and we explained about you can go with fly ash. You can able to reduce why because government is giving tax benefits those who are going for new materials like fly ash, GGPS, fiber reinforced concrete. So we convinced and he convinced he's ready to go for 10% of fly ash. Actually in our university we went with the footing. So in the footing we went with the maximum of 40% of fly ash. So this is the another image like staircase sectional details everything. So this is the after completion of your PCC. This is your podium like car parking area PT slab 1. You can see this is the which one escalator area. And this you can see that this is the entire PT slab 1. This entire area. This is the occupied area. And these places wherever we kept in the outside, that is for car parking. That means to go car driveway. And here inside the opening will be there. You can go with go and park the place there. So this is the reinforcement details. I no need to explain more about reinforcement details everything. Just I took as a case studies, and you can see here. This is the place where drop will come. So drop we went with wooden boards. So you can see here. So remaining place, client is not ready to invest more amount. So he went with the steel boards. So the here and there we can think about any replacement, which material we can use continuously for more than 10 to 12 project. So like that we can think and we can proceed. So we are working on that further. And next one is PT slab, I no need to explain about everything. And after that we did some testings. So you can see here concrete, how much amount of concrete we are using from the morning to evening. Around on the day we used around 140 trucks of concrete. So this is completed structure. PT slab 2. We are going to proceed after the PT slab 1. So this is one video. I think no need to explain more. So this is the day of concreting. So after we are convincing, they will go for 10%. This entire PT slab we wanted the 10% of failures. You can see here. So at the end of the case studies, from this, what I inform to my students means, see, this is the in and around infrastructure we are going. So like this is another project for hospital building. So these are the things will be there. We can think about replacement materials and we can go with sustainability. Actually, infrastructure is needed. We have to go. Why? Because as we are a developing country, we should have to go with infrastructure. In Amravati, total in and around day by day, around so much amount of concrete is delivering to the sites. We itself use per slab around 340 cubic meter. So all together, when we went for entire structure, we crossed around 2000 cubic meter. So that is the one. So that's what I informed to my students to think about, look after about replacement everything. So one of my student want to do on recycled coarse aggregate. So he went with the recycling of dismantled coarse aggregate in cement concrete. And one more thing, you can see here, this is not only aggregate. He will add steel fiber, everything. But once the work is completed, I for next webinar anything, if I get a chance, I can explain to them. So this is the literature review. He done everything and he finalized it. We have to go with reduce, reuse, and recycle, and effective management for the alternating the material. So you can see here he collected the waste concrete and he did with artificial crush, and he divided the particles secondary crush, and he sieve and he clean and dry, and he went with once again for the aggregate. So you can see this is the preparation process of recycled aggregate. And once it we completed, we went with the properties like what is the compressive strength, what is the increasing in strength with steel fiber, without fiber. You can see here without fiber flexural strength, with the fiber flexural strength, and we went with the load versus deflection for the beams. So these are the result and discussion. So again, he went with the life, how much fatigue life is there for a concrete and steel, all those things. So this is one of my student, PhD student. He did and he is working on that. He is trying for steel fiber and he is trying for polypropylene fiber and he is going with hybrid fiber. And one more studies we went, like we went with experimental study on biofibers in concrete. So you can see here how he started his survey, like literature review, and followed by selecting the aspects and the outcome, and followed by materials collection like biomaterial, coir material, bamboo, and plastic optical materials, then laboratory test, then specimen test, and the testing, and followed by result. So you can see, observe, you can see this is the plastic fiber and coir fiber. So these are the different types of mixed details. So from this image, you can see clearly first stage is coir fiber and bitumen coated fiber, then plastic fiber, bitumen, and bitumen coated plastic fiber. So this is the different types of mix ratio, and we will implement in the aggregates, and we will add pesticides, and we will get the concrete. Once the concrete is ready, we will went with some test, and these are the basic test. I no need to explain more about that. So he went with the percentage of adding fiber. You can see here how much percentage he added for coir fiber, 0 to 2%, and the plastic optical fiber 0 to 2%. So he went with this test and what we need to test to know the parameters to check whether it will be okay or not. So that is the one. Then we did the cast of beams. From the cast of beams, the same proportion he used. So finally, experimental setup and the crack patterns. So how much crack pattern is occurring, how it will feel to know the characteristics of the coir fiber and plastic fiber. And this one is the SEM analysis. So SEM and the EDX analysis to know the internal properties of the concrete. You can see here how the voids will be there if I use fibers and if you use other materials. So after that, once the work is completed, we will make it into the document to make the readers and to make the awareness to the researchers to know about such type of work is going on. So you can see here the recycled aggregate, my PhD student, he made it into the paper and he published in the journal. And due to the structural application of fiber reinforced concrete, we got a award, like more number of readers read about this paper and they liked and they get cited about these things. And you can see here next my topic is like first one I set about recycled aggregate, and next I followed by fire fiber and plastic fiber. So you can see here what we made means we are replacing the steel with the GFRP rebars and 20% with fly ash in cement and polypropylene fibers. See, whenever we are going to replacing the material, it's like to make additional strength, we have to add something, or else when we go with normal replacement, you won't get the strength. So that's the reason we are adding here any supplements material. You can see here, this is a steel RC beam with the normal concrete mix, and another one is steel RC beam with PF polypropylene fiber, and another one is RC beam without mix, without normal, without polypropylene mix. And here you can see here with mixed with the GFRP bar. So we implemented GFRP bar. So you can see here, this is the normal mix, fly ash mix. Actually, FF is the fly ash mix. So we did with the mechanical properties. So mechanical properties completed, and we went with the beam testing. So one is normal mix, and another one is polypropylene GFRP parts. So you can see here steel parts and the GFRP comparison, load versus deflection. So how the steel is acting and how the GFRP is acting. So from this, what I need to convey means, so recently we are working with one 12 storage slab building. So how they made the plan means the mode of the project is 2 basement for car parking and remaining 10 floors for residential. So for the 2 car parking, one slab is going to come, so that is your PT slab, and another one will be in the ground. So in the ground, only soil filling is enough. But from the structural consultant, he informed that we need to go with the reinforcement also. So at the time, I got a project. That means they came to us in our KL University to get consulted with about that project. So I and my senior professors are involved on that. So I informed about GFRP parts. At the end, they are ready to go with only main reinforcement is steel bars and distribution reinforcement is GFRP bars. So like that we can convey. We can convey means first claim they are not ready to go with anything, but we have to speak with our result, our experimental work, everything. So you can see this is the normal beam, the crack patterns, and this one is your GFRP beam crack patterns. You can see clearly the normal beam. Here you can get crack, but here this one is the normal distributions. Like GFRP, we added some 20% of fly ash. So you can see here, this is the beam testing for fly ash plus polypropylene beams with the GFRP and the steel reinforced beams. So next one is, see, first I made with one case studies of commercial building. So keeping that commercial building, I went with the recycled aggregate. Then next one is I went with the fire fiber. Next to that I came with the GFRP parts. So fourth one is we tried to work on big area of fiber reinforced concrete beam under vertical loading. So here we went with different type of fibers like steel fiber, glass fiber, polypropylene fiber, and hybrid fiber beams. So we ready to mix steel plus glass plus polypropylene. So that one we tried. So you can see here, these are the materials we use like OPC, 20 mm size of aggregate, and natural Krishna River, and super plasticer we took from the local distributor, and silica film, micro silica. And these are the steel fibers we used. You can see this is the properties of the steel fiber, like mechanical properties, chemical composition. Then you can see here, this is the glass fibers properties, and this one is the polypropylene fibers. That's what we are going to use more than 2, like mixing of polypropylene and steel, mixing of glass and polypropylene. That's what we came with hybrid fibers. You can see here, this is the specimen details we follow, like reinforcement like 2 number of 12 mm diode, 2 numbers of 12 mm diode bottom. These are the normal conventional method, like how we will do the structural design in DRC. So like that we did, and we took. So even I can say, even if you are going with hybrid fiber, you can change your GFRP bars or stirrups. You can go with GFRP bars. You can try for an attempt, and if you get good result, you can make it as a patent, and you can make it as a publication to make awareness to the researchers and the clients. So these are the different mechanical properties we did, like cubes, flexural beams, and cylinders, all those things. You can see this is the test specimen of the beam. Then beam casted for placing in the loading frame. So you can see this is the loading procedures, like how we will keep everything. LVDT machine to find out the exact track in MMs. And you can see here, these are the different properties like steel fiber with 0.75, 1%, 1.25, glass fiber, polypropylene fiber, and hybrid fibers. So these are the compressive strength test you can see from 7 days to 28 days to 56 days. So this is the graph mentioning the compressive test result. And these are the different failure specimens at the test. And you can see this is the split tensile strength what we did for the same compounds. And this is the flexural beam. This is the same compost we did all the to know about the mechanical properties. Even stress strain also we did. We did stress strain also. And finally we found out the load versus deflection. So you can see here beam on load is 246 kilonewton, followed by 301, 253, 248, 340. You can see the deflection at the peak, how much how much the parameters by using 2-point loading. So this is the result what we got from the last case. So these are the different case patterns, like for the nominal concrete mix and steel fibers. This is the control crack ductility and failure mechanisms, all those things. So the same things we did with the ANSYS also. So once we completed the experimental work, I used to inform to my students to go with first analysis, but my students used to do once we will complete experimental stuff to know about the detailed and the clear vision idea everything. So once if it is okay, we are ready to go with the ANSYS. So they went with the ANSYS also. They found out the crack patterns. So it is matched around 10% actually. You can see here, these are the different specimen ID and failure pattern for the experimental result and the numerical result. And the difference is around 10% differences will be there. So this is about experimental and numerical result. So these are the publications. So we are working on more projects like how to make the client to convey to work in the real-time project like FlyAS or GGBS or Cocofine, Alcofine or GFRB rebars. Even sandwich panel also we are working and we are ready to inform to the clients. Why? Because so much villas are constructing for the people, so those who are having less income. So that scheme is implemented in Andhra Pradesh. So they given the land, so they want to construct. So if we get the time, definitely we are ready to say about those things. But to make it everything convey, we should have our clear project vision. The patent, everything will be there. We can able to convey the client. So this last 2 years, when I worked with the clients, so if we are ready to explain all those things, they are not ready to get it and they are not ready to implement. But when they will get any problems, they will come to us. At the time, we will say these are the materials. If we use, we will save the project. At the same time, we can go with the resources. So when I informed about 10% players in the podium slab, like how I previously shown in the commercial building. So client is very happy about that, and he completed the remaining slabs with the 10% of flyers. Actually, I convinced for him to go for 20%, but he said he is not ready to go. So due to the PT slab, all those things, he went with the 20%. And another project I informed to go with the GFRB parts for ground level, only for the ground level parking. So it's implemented. And one place we implemented steel fibers also 0.5%. So we are working on that. So what I need to conclude means, see, infrastructure is main reason. At the same time, we have to think about the sustainability, and we have to very good about the clients. So client, they will simply say, no, we are not ready to use. Why you are compiling like that? We have to say in a very good manner and we have to show with our proof. So these are the research we did in the laboratory. We can try with one small portion of the slab to check it. If the result is not come, we will maximum the result is not come. We should not say. So we can, so many methods are there. NDT methods will be there, and we can check with cube test. So we can find out the maximum it won't come. Actually, we have to convey. So you can see this is the image first I shown you. Like when I designed this one, they said there is no need of open spacing at the center. But I informed that if there is a spacing will be there, it will be get your good ventilation. I try to make the client to go with green buildings, like without any energy. We can make from morning sunrise to sunset. We can make our building with full ventilation. So I informed like this, it will be very good look purpose for the hostel building. So this is one of the hostel building, what we given the structural design. So I convinced actually don't have the architectural plan everything. Actually, their time is very limited. That's the reason I can't able to show those things. So from that, I want to conclude that we need growth development. Why? Because means everyone want to their limited space. They have to construct and they make the people to luxury and they may and make the people to comfortable and give the clients to satisfaction. So infrastructure also need we have to develop. At the same time, we have to think about the sustainability and the alternation of material. So why? Because our resources are very limited. We can see due to the war how the LPG gas problem is there. People are getting panic actually. Government is saying from one side, you no need to worry, you don't think about that. We have the enough of stock is there. You don't worry, but people are coming towards the road and making the things we want LPG gas. So it's like if anything problem happened in civil engineering, it will go in a very rumored manner, like social media. It will develop it. So whenever we are working for the project with the client, so we have to take care. We have to take more things, and we have to go with our case studies, statements, and so many things. So that's what I want to conclude. Actually, my time is very limited. Actually, I got only 30 minutes to complete all those things. So before that, I concluded. If anything is there in further or in upcoming days, anything will be there, we can see and we can. I am ready to share my knowledge with you. That's all, madam. Madam, thank you for the opportunity. I need to say thank you to yourself and organizing committee and IAE members and chairman, sir. Everyone, thank you so much, madam. If you have any doubts, you can ask me. I'm ready to.
Okay. Thank you, sir. Thank you for sharing your thoughts about the innovative geotechnical engineering approaches, and you have presented the papers and the publications and the videos presentation. It was very informative session, sir. So within the short time, I hope all the speakers they covered what all they preferred. Thank you so much for your participation and presentation. So now the question session will start. So I think there are 7 questions they posted. First, so can we introduce rebar in 3D printing structure, sir? Prabhat Ranjan, sir. Sir, are you available? Okay. Sir, this question they posted for
Sorry,
Surendra, sir.
am I audible?
Audible, sir. Audible. So can we introduce rebar into 3D printing structures? So this is a question for you, sir.
Currently, there are limitations in the 3D printing process. That is, main limitation is introducing the reinforcement. So there are we can't introduce the reinforcement just like how we introduce in the conventional concrete, but we can introduce along with the layer printing as a wire, a steel wire. So that's what people who are experimenting. Still, I have not seen a structure which is printed along with the reinforcement as of now, at least in India. So there is attachment which rolls along with the nozzle during the printing process. So along with the layer printing, the reinforcement, wire will unwind itself and print along with the layers. So this is one specific thing which I have studied, but practically nowhere people implemented, and it should be still explored because there are a lot of other problems when we bend the wire or along with the nozzle, the entire material may collapse. So there are certain limitations are there. This is the main limitation, and other disadvantage also there in the 3D printing is that the high porosity between the layers. So when the porosity is higher, the durability is always lesser, right? So this is a major concern from the 3D printing. So still exploration is going on. So yeah, it's like ongoing research is up to this level.
Okay, sir. Thank you, sir. Thank you so much.
Thank you.
So the second question, how may remote sensing help in early warning related to earthquake? So this question is for Surendran, sir. Sir? Surendran sir. Sir is not. This question is for Lingeshwaran sir. The normally PCC leveling force is only 100 mm. May I know why 125 mm PCC was laid?
Madam, I can hear you, madam. Madam, I can see.
Okay.
I'm
Ah.
reading question. 1 minute, 1 minute. Yeah.
Okay, sir.
Yeah, normally PCC leveling course is only 100 mm. Actually, in our place now, madam, see, in our area, the soil condition is very loose. And I said na already, Krishna River region, it is very near to Krishna bed. You can see the flow of water to site is around only 2 kilometers, not 2, less than 2 kilometers, 1.5 kilometers only. So there the soil is very loose, and this is the commercial building, and we are going to keep the PT slab. And yeah, I said already, total 35,000 square feet of area, we are going with around 24 columns. So the 24 column means the each column size is 4 feet cross 4 feet. So each 4 feet, 4 feet, you think how much support reaction will come. So I need to rest it in the pedestal and pedestal to the raft and raft to the PCC. And I already said one more point, there will be a termites problem in our area. So because it is previously 20 years back, it is agricultural land. So here the soil is fertile soil, and due to the Krishna River, whatever things you are keeping for the agriculture, it will grow like anything, madam. We will get very good outcomes. So that's the reason termite will be more. To escape from this problem, we went with 125 mm PCC. It is not that only 100 mm or 125 mm. Maybe your 100 mm, maybe it will be for residential. So this is a commercial. So that's what it is 125 mm. So next question is, please elaborate about the remedial of cracks in concrete, remediation of cracks. Actually, still for about cracks, we didn't went. We are working for which one, bacterial concrete also we are working. So in upcoming days or in further any by under the umbrella of Akshaya College Engineering with IEI, we are ready to give. We are ready to give after 6 months. So the work is going on. If it is there, I will inform. So my next question is, I hope for me no other. How many GFRB were used for this case study shown in Dr.
Yes,
Lingeshwar? Actually, you can see here it's depend upon length and width. So, for example, the 35,000 square feet area, we are going with how much amount of PCC in the ground floor. So, in the 35,000, 15,000 went for development. So, remaining around 20,000 square feet. So, if I say length is 100 feet, width is 75 feet. Just example, I'm saying. So 100 feet means you please, I will keep main reinforcement, distribution reinforcement for cellar is around 5 inch. So 100 feet you converted into inches, around 12,000 inches it will come. So 12,000 inches divided by 5 means it will come around 24 number, 24,000, 2400. So X direction 2400, Y direction it will come less than that. So only main reinforcement with the steel bars, distribution with GFRP bars. So like that, why? Because client not ready to accept for both sides. So like this. So it's depend upon like a mat, your quantity estimation. Depend upon quantity estimation, you can go with that numbers. It's depend numbers is depend upon your site area and your structural design. I said 5 inches. So in your place, depend upon your conditions, you can proceed.
Oh. Sir, one more question for Prabhat Ranjan sir. So, could you confirm the economy of scale for 3D printing in Indian context, considering this appears to be more architectural product if we can't get rebars in currently?
Can you come again, madam?
Could you confirm the economy of scale for 3D printing in Indian context, considering this appears to be more architectural product if we can't get rebars in currently? How will be the economy for 3D printing?
Economy, see, keeping this thing in the mind, without reinforcement, obviously there will be a lot of problems in the printed structure. So that doesn't mean that it cannot be executed. Still, there are alternatives. People use that infill material. So if you see the wall which is printed, in between there is a lot of gaps. So we can introduce reinforcement in the infill, and we can fill with other concrete materials also, keeping this outer printed layer as a shell. That's how people are exploring till. So anyhow, other side of the coin is always there, like as you spoke, like economically it is not feasible. Maybe at the same time, it is very good at printing different architectural designs. Yeah, there is always some kind of gap which is existing in this 3D printing till now, which has been explored. Yeah, this is limitation is there. That's why we tell there are some limitations, and it can be researched and improved. It is not that nothing is impossible. Things are always possible when we keep some effort in the research field and development. Surely there will be a solution in this. Yeah, but other side there it is costly because the material purely the cost incurred in printing may be high, but the cost same time can be reduced by avoiding form work, by avoiding so many labors. In this way, it can be brought down. So much can be brought down. So I think that addressed your comment or question, whatever you passed.
Okay, sir. So last question. Can we use this 3D printer structure at water contact areas? How these 3D printer structures behave when connected with water continuously?
So 3D printer basically a instrument. What majorly performs in the water logged areas is materials. A material that is developed to print in the waterlogged areas means we have to design the material to perform for printing, like to print for its printability. So when we develop a material for a specific performance or specific location and for specific situation, then it can be printed. Yeah, obviously there are admixtures, water repelling admixtures, and which will also work underneath the water and without segregation. So that can be obviously we can mix into the ingredient as ingredients, and yeah, we can develop the mix also. So printer can be located in a specific dry location, or you create the situation in such a way that generally how we construct the pillars in the bridges where continuous running flow of water is there. We create coffer dams, right? Like the dry environment must be created. Dry environment must be created to place the printer. Obviously, there is operational the maintenance things are there. Then you create whatever it is like that. So that is, I think that addresses your question.
Okay. Okay, thank you so much for your valuable answer, sir. Thank you so much. Now I hand over this sessions to Dr. J. Pradeep Kumar, sir, Honorary Secretary of IEA Coimbatore Local Center, to deliver the vote of thanks. Sir Pradeep Kumar, sir.
Yes, madam. Is it audible?
Yes, sir, audible, sir.
Good evening. It gives me immense pleasure to propose the formal vote of thanks for this IEA technical webinar on next-gen infrastructure for a sustainable future under the aegis of Civil Engineering Division Board, IEI, organized by Institution of Engineers India, Coimbatore Local Center in association with the Department of Civil Engineering, Akshaya College of Engineering and Technology, Coimbatore. At the outset, I extend my sincere gratitude to the President of IEI, Chairman of Civil Engineering Division Board, members of Civil Engineering Division Board, council members, and Technical Deputy Director, Engineer Sudeep Chakravarti, for their constant and continuous support for all our activities. On behalf of IEI Coimbatore Local Center, I extend my heartfelt thanks to today's esteemed panelist, Dr. Prabhat Ranjan Kumar Soda, Senior Engineer, R&D, Modulus Housing Private Limited, Chennai, Dr. Surendra Manikam, Associate Professor, Grade 1, School of Civil Engineering, Vellore Institute of Technology, Vellore, Dr. N. Lingeshwaran, Assistant Professor, Department of Civil Engineering, KL University, Andhra Pradesh, for accepting our invitation to address in this program. My sincere appreciation to the Principal and Management of Akshaya College of Engineering and Technology, Coimbatore, for continuously interacting with our IEI Coimbatore Local Center and for the dedicated support in arranging various technical activities. I thank Dr. M. Sendil Kumar, our beloved Chairman, IEI Coimbatore Local Center, for his welcome address and guiding all our center activities. Special appreciation is due to Dr. R. Prem Sudha, Professor and Head, Department of Civil Engineering, Akshaya College of Engineering and Technology, for her efforts in organizing this program. Finally, I extend my sincere thanks to all the participants of this webinar, IEI council members, committee members, IEI corporate members, industry members, faculty and students from various institutions for their participation. On behalf of Institution of Engineers India, Coimbatore Local Center, once again, I thank you all. Thank you, ma'am.
Thank you, sir. Thank you, sir. And the last but not least, I would like to thank our Saravana Kumar sir, PSG College for IEA, for all our IEA activities. Sir only coordinate. So thank you so much, sir. And I would convey my heartfelt thanks to all our IEA members, President sir, Secretary sir of IEA Coimbatore chapter for gave this opportunity for us. Thank you so much, sir. And I would like to convey my thanks to all the participants who patiently listened, even though the time is starting time was delay and the ending also was very late. But you are patiently attended. Thank you so much for all the participants, outside participants, and from our college participants. Thank you so much for your participation. Without you all, this event won't be success. Thank you so much, sir. Thank you, participants.
Thank you,
So
sir.
now,
Madam, I
thank
thank to the chairman, honorary secretary, the panelists, and the moderator for an excellent session, and also to the large number of participants who made this a successful event. And we hope that further also we look in future, in near future, and so that we can have such beautiful technical session with Coimbatore Local Center and PSG College. And I hope our participants will once again make this kind of webinar successful. With the permission of the chair, may I now end the seminar?
Thank
Okay,
you.
sir, please.
Okay, sir, please.
Thank you, sir.
Thank you, sir.